For the delay there, everybody. Okay, my name is John Downey. I'm a business development manager with Amazon Web Services for our storage portfolio of services. We have 8 different storage-oriented biz dev guys around the world. What we primarily focus on is meeting with customers, collecting their requirements, understanding what they want to do, feeding that data back into Amazon so that we can build the appropriate types of services, so that we can add the right types of features. Really getting data back into the company so that we can orient our products in the right way. We're also very linked into different sales opportunities. So we'll find opportunities for our sales teams. We'll actually drive certain opportunities. We work with them, so we're working directly with customers. We're working directly with our sales teams from a training perspective. We're putting go-to-market messaging together, TCR and ROI, overall go-to-market orientation. So we have sort of a unique perspective within the company. The other thing is that each one of us has a different sort of focus. My specific focus is customers that own and operate data centers with an internal storage footprint. So if you are operating block systems like SANs, NAS systems, file, archive, backup, disaster recovery, we actually have the ability to federate those systems with AWS storage so that you can take advantage of the cost, the scalability, the enhanced security posture, so on and so forth. So block, file, archive, backup, DR is really the 5 pillars of storage, if you will. And then I'm going to talk about that in the context of media content, ingest, storage, and archiving. So I also have, I focus on our media strategy as sort of a side thing as well. So that's one of the reasons I'm giving in this. So I'm very happy to be giving this to all of you today. So thanks for your time and attention. I am going to be moving pretty quickly, by the way, today. I have a lot of content. So if you need me to slow down, let me know. But I'm going to keep a pretty quick pace here. Also, this is a 300-level course, so I'll probably end up using some acronyms that, for those of you that are AWS savvy, hopefully you'll all understand. Okay, quick agenda. So I'll run through the AWS components in the context of ingest, storage, and archive. I will then flip to partner-based solutions that can enable ingest, storage, and archive. A quick little note on TCO and ROI considerations. And then one of our customers in demand, Michael-Raposa here, will stand up and talk a little bit about his custom integration with his media asset manager. Okay, that flipped a little early. All right, so for those of you that attended Andy Jassy's earlier session, you probably saw this layout of where our regions are. So we have 9 regions globally, 25 availability zones, 46 edge locations. I want to, edge locations being CloudFront points of presence. I wanted to show that slide and this slide just to reinforce the concept of distributed systems and distributed architecture, right? So per region, you have a variety of availability zones. Availability zones are clusters of very large-scale data centers. So just to give you an idea of what I mean by large scale, I know that there was a statistic updated yesterday, but I didn't see it yet, so I'll use the 2003 statistic. We were a $5.2 billion company, $5.4 billion company, excuse me, and that was a lot of infrastructure, capacity, storage, server network to power Amazon.com. That same amount of capacity we add to AWS every single day. So just thinking about the operation alone is kind of mind-boggling, and then when you think of the size of the actual data centers, they're very significant. So in an availability zone, you have clusters of these data centers that are co-located near one another, and then the availability zones are all connected on high-speed private fiber, anywhere from 5 to 25 miles apart from one another, depending upon which region you're in. So take that concept, and then we overlay the concept of distributed software frameworks, let's say Glacier, which is our penny per gig per month, cold storage, archive, play, or S3, which is a distributed object store. Those are distributed across all these availability zones, across all these data centers, right? Which gives you this high degree of resiliency and data durability so that when a client or a technology or a gateway sends a file into S3, we're actually taking that file, we're chopping it up with our own proprietary parity algorithms, replicating those objects and those bits around the different data centers such that we're designed for 11 nines of durability within a given region. It's automatically advancing, by the way. so I don't know if you can turn that off. So I just wanted to give that as sort of a foundational concept of distributed architectures, and that is a foundational architectural trait of both Glacier and S3. So if we move quickly into the ingest options, there's 3 different AWS technologies I want to talk about. Direct Connect being a private connectivity option into AWS, import-export being a physical disk shipment option, actually a very popular service, as well as the AWS Storage Gateway, which we recently just added VTL modules to. So we can present LTO4 now, which is pretty cool from our VTL, and also has Glacier integration along with S3. Another common theme, though, in addition to distributed architectures, is this concept of parallelization, parallel uploads, multi-threading, concurrency, so that you can optimize your transfers in and out of the systems, right? So what I want to discuss are 4 different performance optimization tips and tricks: multi-part upload, request rate optimization, TCP selective acknowledgement, and window scaling. So let's talk about multi-part upload first. So what this is, enables you to take a large object and chop it up into multiple parts such that you can send those parts in concurrently, right? So how do you start with this? You implement the AWS SDK for either PHP, Java, or .NET into your application, or we have a variety of libraries that you can use in conjunction with the REST API and S3. You will then, to initiate an upload, you'll end up getting an S3 a unique identifier back called the upload ID. Then for every single part, individual part of an object, of which you can have no more than 10,000, we'll assign a part number. And then for every part number that you submit, you'll get what you call an E-tag header in response. And you're going to correspond those E-tag headers to the part numbers. And then what you'll do is take the ID, the part numbers, those E-tag headers, and submit that to have a complete multi-part upload request. And at that point, we will actually concatenate all those parts in S3 into one object, and then no individual parts will exist after that. You can also append metadata to the multi-part upload object as well. So that's kind of the high level, mid-level, if you will, of multi-part upload. Then the next piece to discuss, and this keeps advancing, so I apologize, is request rate optimization. So this is essentially a naming scheme. So if you have an application or a workload that's really chatty and it's mixed in the context of get, put, list, delete, etc., that can cause hotspots on an S3 index on a specific partition, right? And the way that S3 stores key names in a partition is based on your key name prefix, right? So if your key name prefix is alphabetical or sequential, there's a high likelihood that if you have greater than 100 requests per second and it's alphabetical and numerically named, there's a good chance that you could create a hotspot on a single partition, which will increase your latency, and that's bad, right? So how do we reverse that? What you want to do is you want to inject randomness into your key names so that the prefix of the key name has a set of random characters which will ultimately distribute that I/O load across multiple partitions. Right? This is actually something that a fair number of customers and partners don't know. So this is a great piece of information to understand. So 2 ways to do this. You can take the key name and reverse it, which will inject some randomization, or you can take an MD5 hash of that character sequence of the key name and then take a specific number of characters from the output of that hash and implement that as your prefix. And that's also a very common trait, right? So this, again, spreads the I/O load across multiple partitions. You get lower latency. It also gives you greater scalability as it relates to requests for a specific workload. 2 network-oriented tips and tricks. TCP window scaling is the ability to improve throughput for window sizes larger than 64 kilobytes, as well as TCP selective acknowledgement, which essentially increases recovery time after a significant number of packet losses. And so what it does is it actually more intelligently retransmits only dropped packets instead of all of them. So it's a little bit more of an efficient way to optimize your network connection. Okay, so to Direct Connect. So this is a private connectivity option to AWS, very popular with enterprises, very popular for bandwidth-heavy solutions, a cost play over internet, actually, which usually you would think is the lowest cost, but it's actually for heavy bandwidth outbound, meaning out of cloud, Direct Connect can be lower cost because we fix the outbound pricing at a much lower cost than a tiered pricing model than you get with outbound internet. So that's something to consider. There are a variety of requirements for Direct Connect that you want to consider. So first of all, you'll have your network, so it could be point-to-point and a PLS. You got to pick a region that you want to peer your network with. So we have 11 different telco hotels, I'll call them, around the world where our physical routers are stood up. We have 1 and 10 gig ports that you can physically terminate your network on. So it requires you to either be co-located at one of these facilities, or you're going to work with a Direct Connect partner, which we have in our Amazon Partner Network, a variety of different carriers, as well as independent service providers as well. So those are one of those 3 you need. In addition to single mode fiber, gig or 10 gig, 802.1q VLANs, so you can address a variety of interfaces, both public and private, and then support for BGP and BGP MD5 authentication. So if you're going to address private endpoints in a VPC, so for those of you that don't know what that means, that's a virtual private cloud. That's essentially a network quarantine where everything within that network is behind your firewall. You need to provide us an ASN number, configure a virtual private gateway on the AWS side of the VPN, implement your customer side gateway, which could be software or physical, and then a list of all these supported devices and software is on the FAQs for the VPC on our website. If you're going to address public resources like S3 or Glacier or EC2 that may fall outside of a VPC, we need public ASN numbers, public IP addresses for each BGP session. Okay. So ultimately what you're getting here is a much more consistent network experience versus internet, higher throughput, lower latency, and again can be a cost play for bandwidth heavy outbound. There have been some recent additions, so you'll notice that I'm showing 1 and 10 gig port options. We actually just included a whole bunch of other bandwidth options less than a gig. So we start at 50 megabytes now, megabits, excuse me. Then 100, 200, 300, 400, 500, so it starts at 3 cents per port hour if you're at 50 megabits, and then all the way up to 30 cents for a gig, for 10 gig, $2.25 an hour, and this is all on the updated website for Direct Connect. It's very common to see customers not only take this private connection, but also do some sort of UDP, fast file transfer technology over it, and or WAN acceleration. So it's common to see customers implement, for example, Riverbed Steelhead WAN acceleration technology where they'll have the hardware appliance on premise, and then they'll light up the Steelhead AMI on AWS to optimize the throughput on that link. Or you may see scenarios where you're using Signient or Aspera, for example, to have a much faster than FTP experience over this private connection. So that's very common. We have a publisher in New York. They have 140 terabytes worth of data that they're looking to back up. They're actually using net backup with our storage gateway, which is a nice SCSI appliance I'll get into more in a moment. And then it's creating a local disk cache for LAN and disk speed, and then it does an asynchronous copy of all that data over Direct Connect, ultimately residing on S3 on the other side. You can see the locations. So we have 5 locations in the States, 1 in New York City, 32A of A, Tribeca, that's where I'm located in New York. 1 in actually 2 locations in Los Angeles, Virginia, San Jose, and Seattle. Then you have 3 in Asia Pac, Singapore, Sydney, Tokyo, 2 in EMEA, Ireland, and UK, as well as Sao Paulo in Brazil. So very, very popular solution here. Probably, I would say, the most common connection solution that we see customers implement for lots of data, 500 terabytes on up, or sometimes multiple petabytes that customers want to ingest. We'll line up multiple 10 giggies for a period of time. There's also a variety of the different telco partners I mentioned that have specific plans, like burst plans, bandwidth burst plans that are more cloud-like in their cost orientation, if you will. That works specifically with Direct Connect. So import-export. This is a physical disk shipment option. More popular than you probably think. We can accept consumer-grade drives, USB 2.0, 3.0, for example, all the way up to more RAID-oriented devices. We can't accept anything beyond an 8U, 50 pounds, 16 terabytes, and with those devices we can accept SATA and eSATA type connectors. What you'll do is you can do one of three things to initiate a job. You can leverage our Java SDK or our REST API. Most customers just download our import-export web service tool to create and manage these jobs, and that'll step you through a workflow of what you need to do. Drive types, printing off mailing labels, what you need to pack it in. So all these directions are explicitly stated on our website, and then that tool will help you initiate and manage your jobs. Once you send it in, there's actually going to be a courier handoff point where we then take it privately to our facilities, and then those drives will be taken to physically manned stations where there's going to be shelves of different port types, USB 203 SATA and eSATA, where we can then do high-speed local ingest and move that data directly into S3 Glacier or EBS, and we can do the same thing for export if you're looking to rapidly get off of the platform. So I'd say the most common use case for import-export is for initial content migration into AWS. Cost $80 per storage device, $2.49 per data loading hour, and then the standard prices apply to S3, EBS, and Glacier. Okay. Let's move on to the storage gateway. So this is an on-premise virtual iSCSI storage appliance. So these are bits that you can download from our console that you can implement onto either Hyper-V or VMware hypervisors. And what this will provide is a local iSCSI SAN, right? So a block iSCSI oriented interface for applications that require a block interface in your data center. So you're going to obviously require server hardware to run this, your hypervisor, network, and disk that you're going to build. Maybe you have some left over or sitting around that it's already a sunk investment, which this can come in very handy. Common use cases for the gateway is it's really more of a disaster recovery and backup tool. So for example, you could put a file server over our gateway, and then you just kind of built your own little NAS. So you could take a Windows file server, a Linux file server, and have an environment you're familiar with a very scalable back end. You can create up to 150 terabyte cache locally with our gateway, and then it'll snapshot and move all those data sets, all that data into Amazon in the form of an EBS snapshot. And which is really cool is we actually transform those incoming snapshots into an EBS formatted volume, which at any point we can pull out of S3, put into EBS so that you can do disaster recovery on us. And it's an extremely low cost price point, which I'll show you in a minute, which makes it especially compelling. So for the on-premise cache, there's two different modes. There's a stored volumes mode. So stored volumes mode is essentially a full replica. So you can have up to 1 terabyte volumes in stored volumes mode, and then whatever is local, up to 150 terabytes maximum, will get backed up into S3, again in the form of an EBS snapshot. If you use what you call cached volumes mode enables you to have a much smaller footprint. It's not really a mirror like stored volumes mode. It enables you to have, let's say, a 10 or 20 terabyte cache, and then perhaps 500 terabytes in the cloud. And it looks like the 500 terabytes is all local, right? So we actually virtualize the location of the data like just about every single gateway does on the market. So that was a very popular ask, so we implemented that. We've had really good customer feedback so far for the stored volumes mode. It's in the ingest section, right? So why would I put this in the ingest section from a media perspective? Well, you can use it, I don't want to call it DR ingest, but you can at least access the data in sort of a DR mode in the cloud. Or we came out with our Amazon AWS Storage Gateway AMI. So it's available as an AMI, which you can light up in the cloud now, and then essentially make that the primary AMI, which now you have an iSCSI block interface that's running on EC2 that you can mount to other applications, and there you go. It could be a point of egress. It could be a point of processing for all of that data in AWS. We have Lionsgate using this gateway as internal corporate IT backup with backup software. So that's probably the most common use case is when customers use backup exec, net backup, Commvault, variety of different backup software, and they use us as the target volume. And oftentimes you'll see those backup software implementations doing the deduplication, because we don't do dedupe. They'll do the compression. We do compression also. The backup software will do the encryption, the key generation, et cetera. So we can offload a lot of those functions to the actual backup software, assuming it's supported with a block interface, which some backup software it's not. So it can get a little complicated, by the way. And then another common use case I mentioned earlier is the file server over our gateway, just creating your own low-cost NAS that's either Linux-based or Windows-based. TV Tokyo is another one. They're backing up their file servers. The easiest way to do it is actually put the file server over us, and then our snapshots are the backup. But they've chosen to keep their backup software separate and use backup servers separate, and then use backup software to move the data to us as the target. So that is the gateway. We offer it for 60 days for free for testing purposes. We also offer a gigabyte of snapshots for free per month for the first year for new users, as well as 15 gigabytes of outbound bandwidth, only again for that first year for new users. After the 60-day trial period, it's $125 a month, plus fixed 9.5 cents a gig per month for volume pricing and snapshot pricing. That's in-cloud pricing, and that's also analogous to what the cost of an EBS snapshot is. And then for bandwidth out, it's consistent across all services, which is a tiered pricing model starting at 12 cents per gig outbound and goes down to 5 cents per gig if you have lots of data that's headed out. Okay, so an exciting addition. We released this last week. Not sure if you guys have seen it. It's on our homepage right now. So we have our own virtual tape library component now that we've added to the gateway framework. So we can now emulate 10 LTO4 drives, 1,500 virtual tape slots, and ultimately your backup software can now see an LTO target, which is pretty compelling. So again, we can create that same 150 terabyte cache as you can in the iSCSI gateway, and then you have two components that you need to understand. There's the virtual tape library, which is, think of that as the local storage and S3. So backup software sees LTO, you hit LTO, hits local disk at LAN and disk speed, creates a local cache, and then that cache gets replicated into S3, also in the form of an EBS snapshot. And then in that scenario, you will get instantaneous disk and LAN speed restores as well because it's still on the disk in that cache. What's really cool is that you can, in your backup software, click eject, where we will then emulate a robotic arm pulling a cartridge out of a tape slot, putting it on a shelf. So when you see VTS, or virtual tape shelf, that means Glacier. So what we're actually doing with the data is we're then deleting the local object and freeing up that disk space and freeing up those blocks in the free block pool. And then the object that sits on S3, you're then dropping into Glacier, which is analogous of your tape being offline, perhaps at Iron Mountain, for example. So it's a tape replacement solution. It's also an off-site tape replacement solution. And by the way, our pricing is designed such that you will not pull data out of Glacier often, or lots of data in a short period of time. When you put data into Glacier, it's meant to be a long-term cold storage archive. In fact, if you pull data out of Glacier before 90 days, there's an extra charge for that. So there are some devil in the details, I'll be frank with, as it relates to Glacier pricing for restorations and pulling data out. But as long as you're using it appropriately, it's typically extremely cost-effective. Encryption supported in transit. And at rest as well, we have what we call server-side encryption on S3, which is a free encryption service where we'll encrypt, we'll generate keys, and we'll manage the keys for you. Glacier encryption is a default. And then we also have the AMI for this as well. So this is a key story. So for those of you that are dealing with backup software, it's very common to have a global enterprise standard for a particular backup software implementation. So whether that's TSM or NetBackup or Commvault, you want that single pane of glass to manage all your locations. So with the VTL, what you can do is have those media and master servers deployed at your worldwide locations, have the agents deployed on the backup servers you're going to back up, and then you target those data streams to hit our VTL locally, and then we'll then create that local cache and ultimately move the data to S3 and Glacier. Okay, fine. What's also common, and this is where the game gets changed a little bit, is customers will have other applications they're running in the cloud, and they want to maintain that single common global enterprise standard. So you can implement the same media servers for that same domain backup software, implement the agents on the EC2 servers that are running in the cloud, light up the gateway VTL AMI, so you have that in the cloud now. And now on both sides, you have the same type of tape target. It's going to the same S3 and Glacier account, all under one single pane of glass, which is your original backup software, which is very cool. So that's something to think about, and that kind of slides nicely into what we can do in the backup space. We're seeing decent speeds, 90 megs between the client over iSCSI and our device, and then between our device and S3, we're seeing about 55 megabytes per second. Very focused on that performance, by the way. You can expect to see constant increases there. Same story around 60 days for free for testing, $125 per month, again, same as the gateway. The virtual tape library, again, that's S3. Again, that's 9.5 cents a gig, which is analogous to EBS storage. And then a penny per gig per month data storage on the virtual tape shelf, which is the offline Glacier storage. You'll notice the retrieval from the tape shelf, which is retrieval from Glacier, is expensive. It's 30 cents per gig. So if you're pulling a lot of data out, that's not a good idea. So again, be choosy with how you're using Glacier here to minimize your costs. Okay. Going to flip now to our storage platforms. So three relatively well-known storage platforms: EBS, Elastic Block Store. That's our in-cloud, higher I/O, block-based storage system for EC2 instances. Then we have S3, which is a high-performance, highly distributed 11 nines of durability object store, and then Glacier, which is also 11 nines, but meant to be a tape replacement cold storage system. So let's go ahead and get into those. So EBS. So for those of you that have dealt with more traditional SAN systems on the market, you know that they can get very expensive and very complex. The sales cycle and procurement itself is complex, not to mention the fact that you've got multiple controller heads and trays of disk and associated network and multiple bays and redundant fiber channel fabrics and host bus adapters, and all the firmware needs to be in line and all the interoperability, and then you're going to replicate that for disaster recovery. It's accepted, and it's a mess, and it's very expensive. Now, for applications that are candidate for the cloud, the story changes quite significantly as it relates to block storage. You have a team with AWS that's completely dedicated and managed on focusing on EBS internally, where you can now create and establish an on-demand, high-performance block storage system that you can mount to EC2, where you only provision what you need, not only from a storage perspective, but in many cases from an IOPS perspective, and only pay for what you use, which is very cool. So that's tremendous value. It also has integrated snapshots, so we can snapshot all the data to S3, which is your backup. That snapshot software is free, but the landing space costs 9.5 cents a gig per month. We also enable cross-region replication, cross-region snapshots actually, so you can snap from one region to another. That landing space is also 9.5 cents a gig, so that's not free. But we do also replicate the volumes within a region across the availability zones. That's actually included in the price, and that replication software is also free. So we believe this is big value. And then what we've done is we've worked on the performance aspect of it. Originally, it was 100 IOPS per volume, which caused pain. We still have standard volumes. They're typically used for boot volumes. Now we came out with something, I think about 6 or 8 months ago, called provisioned IOPS. And what provisioned IOPS enables you to do is establish dial up to 4,000 IOPS per volume. And then you can stripe or concatenate your volumes to get higher I/O if you need to go beyond that, ultimately to the point where the network will become the bottleneck. So what we've done to help get around that is we've created this other component called EBS optimized instances. So certain EC2 instances that have dedicated network pipe between the instance and the volume. So depending upon the instance type, you'll get either a 500 meg dedicated pipe, a gig, or if you're on our cluster compute nodes, which actually have 10 gig NICs and pipes, I think that you hit maybe a 2 gig limit on that. I'm not 100% sure on that, but obviously more available bandwidth on our 10 gig systems. I think I moved forward here. So what you'll see in the context of media systems, customers maybe run media asset managers, digital asset managers. This is where computation occurs. This is where processing can occur. I should say really processing. This is also where the higher I/O transactional components of the MAM or the digital asset manager will take place. Media Silo, for example, is a really cool media partner of ours that has their own embedded media asset management system. The transactional components are leveraging EBS on the back end. It's also very common to see customers implement a variety of scale-out file systems on us. So we actually can do 7 different scale-out file systems on us today that can be a little bit of overhead to manage some of them, but if you need it, we can do it. And they'll commonly use EBS-optimized instances with provisioned IOPS as well to give you a higher file serving scenario. Okay, so pricing for EBS, you have standard pricing at 10 cents per gig per month and 10 cents per 1 million I/O requests. If you go into provisioned IOPS, you're looking at 12.5 cents a gig per provisioned storage, and then 10 cents per provisioned IOPS a month, and then again that fixed price for EBS snapshots at 9.5 cents a gig per month of data stored. Okay. Hopefully that gives a decent overview there. S3. So highly distributed object store for an object storage system, a high performance system, especially when you implement those tips and tricks I mentioned earlier. Geographically distributed, 11 nines of durability. Obviously it's used very often for backup and archive targets. Quite frankly, I'm fairly certain it's most frequently used as a production backend. So this is very much used to be a high concurrency scenario for production applications. And then we have two different flavors of it. You have reduced redundancy storage, which gives you 4 nines of durability. So think less parity overhead, less disk consumed, about a 30 to 33% savings on that tier of disk. And then we have standard S3, which is 11 nines of durability, more parity overhead, more disk consumed, about 30 to 33% more expensive than reduced redundancy storage. So it's a good use case for RRS versus a standard. So in the context of media, you may send in a mezzanine file that may be stored on S3, and then you want to transcode it into different file formats because you have a variety of different consumers on device types and different endpoints. So you'll run transcode jobs in the cloud, and then you can put those transcoded files in different RRS buckets, or in an RS bucket, if you will, and make that origin for CDN, for example. And if something were to ever happen to that particular file, you could just grab the mezzanine file, retranscode it, and put it back, right? So, and if you have a lot of data post-transcode, it can be a considerable savings. From a security perspective, we got a variety of authentication capabilities and security techniques, from IAM integration, which is essentially permissions and restrictions, the ability to put multi-factor authentication on deletes for versioned objects. So if you have a versioned object and you go and try to delete it, you need a key fob and a code that you have memorized. We actually do MFA for a variety of different services around AWS. We also have access control lists, bucket policies, query string authentication, server-side encryption, which means encryption on S3, as well as HTTPS supported, of course, out of the box. So, Netflix, tremendously large user of S3. So is PBS. Also, Samsung uses their video communication, stores those videos on S3, and also does the recording, transcoding, and storage on us. Tremendous growth on S3. This was Q1 of 2013. We hit over 2 trillion objects. We're now in the trillions of objects. So tremendous growth there. I don't know what exactly the stat is. And then from a pricing perspective, you have a tiered pricing model, and you'll see that roughly that 30 to 33% delta between standard and RRS. And as you guys saw earlier this morning in the keynote, if you were there, we've done 39 price reductions to date. And on S38, AWS wide, and on S3 alone, we've done 10. So we've done 5 storage reductions on the pricing, 4 on the bandwidth out, and then we made bandwidth in free July or June of 2011. Okay, Glacier. So tape replacement, cold storage. Lot of interest, lot of customers using this right now. Total game changer. When we collected the data on building this product, a penny per gig per month was the magic number. And remember when we talk penny per gig per month, you may in your head, if you deal with media and tape, you may be thinking, oh, that's much more expensive than my tape implementation. Well, you have to understand that this includes everything. This is power, this is facility, this is network, this is durability, this is the whole pie, right? To give you 11 nines of durability with a significantly enhanced security posture, a penny per gig per month is very competitive. So what we'll see here, you'll have more of an experience of synchronous in, just like S3, so it can handle lots of concurrency and inbound. Outbound, though, we're a little bit more constrained on purpose, right? So it'll be roughly a 3 to 5 hour wait time when you issue a recall out of Glacier, and there is a pricing model around that I'd be happy to discuss with you guys offline that you want to make sure that you understand. So once again, if you use Glacier, great to put data in and leave it there. If you pull data out prior to 90 days, you're going to get dinged. If you're pulling a lot of data out in a short period of time, you're going to get dinged, right? So it's a model that we can help you with. We also, real quickly, Michael-Raposa from InDemand, who's going to speak later about this, did a really cool project where they integrated their media asset manager directly to Glacier. And what they're doing, and we'll get into it more later, which is just really creative, is they're taking all their tapes, restoring them back onto Isilon disk, and then using his integration in his media asset manager to grab those objects off Isilon and put it into Glacier to get rid of tape, which is pretty cool. The other thing to consider with, and I kind of consider this a fourth product, is the tiering connector between S3 and Glacier. So we call it our object lifecycle management capability, which we can drop objects from S3 into Glacier programmatically based on time and prefix. And this is actually, I would argue, probably the best way to integrate, only because, and it depends on your use case, obviously, but because when you go through S3 to Glacier, there's a lot more levers, if you will, in that API. It's a much more rich API. So if an object got ingested through S3 and gets dropped down into Glacier, that object in Glacier maintains all those S3 API attributes, which makes it a more powerful integration. So you'll see certain customers do native integration through S3. A large American Spanish broadcaster runs their syndication system and media asset management on AWS. They have about 130 terabytes on S3 that they're looking to clean up. And so they're integrating their current S3 integration. They're integrating the object lifecycle management capability to drop that 130 down and just dramatically lower their cost, their monthly cost on storage. Another example, partners are usually going through the S3 API versus directly to Glacier. So Riverbed Whitewater is a really good example of that, where they will, it's an on-premise backup appliance where you'll have backup software hit CIFS or NFS shares. It'll do dedupe compression, encryption, local caching, and then move everything into the cloud through S3 with a 0 timeout value directly into Glacier. So you'll have, let's say by default, a 60 or 90-day cache on-prem, which means chances are all your restores are going to come from that device on-prem instead of pulling it out of Glacier, and you have all your data geographically distributed on an 11.9s backend at a penny per gig per month. It's a pretty compelling solution, especially when you can get high degrees of deduplication. Okay, so that is the storage story. So now I'm going to pivot to partner solutions. By the way, this clock didn't start on time, so if you could tell me when how I'm doing, that'd be great. Okay, so let's talk about, I got four, only got three on this slide, but I'm going to talk about here. The first is Aspera, so a longtime partner, fast file transfer, significantly faster than FTP. They have an as-a-service solution implemented on AWS. They've been well-rooted in the industry. Attunity is another very cool fast file transfer technology that's also SaaS-based, a little bit more broad in applicability, goes beyond just a file transfer. And then Signient, which is a newer addition, also has a service that they're offering on us. That's also a heavyweight as it relates to fast file transfer in the media space. Okay, so for Aspera, they just recently won an Emmy, for those of you that don't know, for their FAST protocol. So that's pretty cool, so congratulations to them. You can light up Aspera on AWS either by bringing your own license for our implementation, or you can go to Marketplace and light up an entirely new instance. Their architecture is a client that can either be a web client, a variety of different clients that will communicate with their inline server, if you will, or implementation on EC2. And then the data will move through that server down to S3, and the integration from the server to S3 is highly parallelized, and you can scale out that middle in-band area. So really good performance, up to a gigabit per second per instance. So if you scale out, that can get pretty significant. 10 terabytes in 24 hours of data ingest, roughly. And then what they've done is they've integrated into the greater ecosystem of partners running on us. What's that say? 2 minutes left? Okay, thank you. I don't know what that, I need to know how much I have left. Okay. All right, thanks. Okay, so what they've done is they've actually integrated with Zencoder and encoding.com, which is kind of neat. And of course, they're very easily integrated into your workflow as well. So there's some pretty cool things that you can do with Aspera. That same Spanish-American language broadcaster I mentioned earlier uses Aspera to ingest 15 megabyte files to us, where then their syndication system picks it up, moves the file into a transcoding scenario, and then stages it into an S3 bucket for as origin for a CDN. Also, Netflix, huge Aspera user with AWS, and then one of Netflix's largest competitors that I can't name by name, also uses Aspera quite a bit with AWS as well. So this is an awesome partner. Attunity, a little bit more broad, 10-year-old company, NASDAQ listed, services the enterprise. They also can do fast file transfer, so you'll have, again, a client on one side, and then it'll run through a stack of servers that will then communicate down to S3. But they can also do movement of data from heterogeneous sources and targets. So not only can you move files between different types of file systems, or file systems into S3, or file systems into Glacier, but you can also, I call it a mapper, remover, and a loader, where you can also plug it into SQL and move the data to Oracle, or MySQL and move it to SQL, or Oracle to Redshift, right? So it plugs into Redshift and EMR, which are AWS services for data warehousing and Hadoop, and then you can also connect dissimilar databases, and it'll do the mapping between the databases, which is really interesting stuff. And again, this is all done as a service on AWS. So pretty cool technology. There's a large company that has a gaming division that uses Attunity to move their digital assets in and out of AWS. Okay, Signian. So Signian is a different type of architecture. So you've heard me talk about clients moving data over an accelerated protocol through sort of a core. Signian is different. They're out of band. So you can put a client in one location, put another client or agent in another location, and the data moves between those agents, and the control plane is out of band. So they have now their control plane operating on AWS as a service called Media Shuttle, and then you can implement your clients at any source and target. And one of the targets can also be a Media Shuttle server, which will then move the data through that server down into S3 as well. So sort of a similar interface as far as moving data into Amazon. So we're pretty excited about Signian joining. And then the fourth and final I'll talk about from a data movement perspective is cycle computing. So cycle computing, their DNA is really rooted in high-performance computing orchestration. In fact, they just set a record yesterday. I can't remember. I think they had something like 16 or 17,000 instances they ran in a single job that produced X millions of teraflops, making it the 29th largest computer in the world, which is pretty amazing. They just did that yesterday. One of the components in Cycle servers called DataManager. DataManager is a data mover and a data orchestrator. So you can put DataManager in front of any type of file system. Some NAS systems, for example, are closed, right? They don't enable you to plug in through a backdoor and drain stuff out using HSM technologies, which is hierarchical storage management. A lot of that you can't do with certain systems. So what you can do is take technologies like DataManager, mount those shares, and then suck it out through the actual share to the target, which can be S3 or Glacier, and then it can actually issue commands to delete the storage on that local disk. And there's some pretty interesting recovery capabilities as well. So visual effects companies, for example, will use DataManager to move assets into the cloud, and then they'll actually also orchestrate where the computation takes place. So in other words, they'll orchestrate standing up large render farms or transcode farms, run the job. So they'll automate, move it, they'll audit, they'll encrypt it, they'll report on bandwidth usage, and then once you create a good asset, it can automatically put it in S3 and Glacier, and the job is essentially complete. So this is a really cool technology. Okay, now I'm going to pivot into the storage solutions. So two partners I want to talk about, two pioneers in the space, especially Panzura being a pioneer, is Veer and Panzura. Veer's newer entrant to the space. They're going to be releasing their integration by December, and Panzura has been out for 3 years. I'm not even sure how many years with us, more than that, 4 years? Okay, and they're really one of the first to create global namespace NAS, so we'll talk about both these in a moment. Before I get into it, I want to make sure that you understand the concept of a gateway. So I know I talked about our VTL, I talked about our gateway, but let me just make sure it's very clear what this is. So if you consider status quo, or the way things are or were, you would have SAN on-prem, NAS on-prem, all the complexity and costs around that, backup servers to back those systems up to other storage targets, tape, disk, VTL, et cetera, and then archive platforms, all in one location, which typically all gets replicated, and then with tape out as well. This is common, it's expensive, it's complex, and it's been accepted, okay? If you look at the way you can leverage gateways to change this model, is let's just take the NAS example. So I can take a NAS filer head, implement it on-prem, You get LAN and disk speed, read and write scenarios because it'll cache data locally for a period of time. So from a read and write performance perspective, for certain applications, it should be just like a traditional NAS. Once the data hits that device, it'll do variable block length, or depending upon the vendor, variable block length deduplication, plus compression, plus encryption, plus key generation, plus key management, plus do WAN acceleration using those tips and tricks I mentioned between that device and S3, and then move a copy of all the data into S3, cache the hottest data local, right? So you may have 500 terabytes in the cloud, maybe you have a 30 terabyte cache. You see the full 500 terabytes as if it's local. There's also embedded snapshots, so you have never-ending snapshots in time in the cloud, which means you don't need backup software, backup hardware, tape, offsite tape, and it also evicts older blocks or older files out of the cache based on policy, which means you don't need archive software and archive targets because it's all bundled into that single operating environment. So you're talking about a tremendous difference in the stacks of what you have to own, what you need to manage, what you need to capitalize. And while you've done this, you've dramatically lowered your capital investment. You've dramatically increased your scalability. You've enhanced your security posture because everything is encrypted at the source with keys that you're generating and manage. And by the time it gets to us, it's a scrambled binary blob. And that means somebody would have to get into your S3 or Glacier account first and then try to access these bits that are then, of course, chopped up and moved across geography. It's a very, very solid model. So you can see why technically and why operationally as well as cost-wise this is very compelling. I'm not saying it's a fit for every single use case depending upon performance and requirements, but for tier 2, moderate I/O use cases for some of these, it's very interesting. Some of these as well can provide global common namespace across geography. So think of Microsoft DFS, but just a much better experience that actually can do file locking across geography. So they'll do global namespace, global locking, and global deduplication, which is really tremendous. Okay, so let me talk about first partner, Avir. So Avir is been around for about 4.5 years. These guys are pretty, they invented a company called Spinnaker that NetApp acquired, which is now NetApp's GX technology. And then they left NetApp and they started Avir. And what Avir is essentially a NAS accelerator. So you have client Ethernet, Avir nodes Ethernet, backend NAS. And Avir dramatically accelerates the reads and writes and re-tiers where all the data lives in that ecosystem. They were able to beat two very popular NAS vendors from an NFS IOPS and throughput perspective. It's on specfs.org. In 2.5 racks, they were able to beat one vendor that had a 7-rack implementation, another vendor that had a 12-rack implementation. I think all of them were SSDs. They did it in 2.5 racks. So the cost per IOPS for these guys is significantly low. And what they're doing, why we're excited about it, is they're announcing at the show their integration with AWS. S3 will come out at the end of December. I think they're starting their betas right now. And then at the end of March, they'll have Glacier integration. So what this means is that you can put Avir nodes in front of your existing NAS implementation, which is a 3-second namespace cutover. So it's essentially non-disruptive, if you will. And then you will accelerate your existing scenario. So the backend NAS, whatever you have, just becomes a capacity tier. And then you can turn on a piece of software called Flash Move, which will copy all the data in that existing NAS through these heads, non-disruptively, namespace maintained, everything's accelerated, copy all the data out over the pipe into S3. So if you have hundreds of terabytes, it may take a month, depending upon your bandwidth and file types. Once that full copy is over, you can then switch the mode in their cluster. By the way, their clusters scale out. So you can scale it out to 50 nodes, which is a single file system that stripes very fast. And once that migration's over, you can flip the mode, turn on their file system, and then non-disruptively decommission and retire the other backend NAS, which is a really, really cool, exciting thing that we think is going to do really well in the market. So that is the Avir story. Visit them at the booth. And then Panzura, they're also here as well. So Panzura, they're essentially, again, NAS over S3 in Glacier. So they're filer-oriented technologies, so you can put filers in different offices around the world. They also just came out with an Amazon Machine Image, which means they can also operate as an image on AWS, and that means you can extend a common global namespace with locking and global deduplication across all your locations and into AWS and across AWS regions. Thank you. Perfect. 10 minutes left? All in. OK. I'm almost done. Sorry. So that means that for DR scenarios, there's no concept of failover and failback. It's essentially active-active read-write everywhere. So very cool partner here. Very cool starter packages that you should take a look at. Also a bunch of AMIs they just released as well. OK, this is real quick. There's lots of complexity in TCO and ROI. So please work with us when you're trying to do this. We see customers do it incorrectly almost all the time. So we have people hired with pretty awesome degrees to do just exactly this. So we can help you here. Thank you guys for your time very much. This is my contact information. If you have any questions, feel free to reach out to me or call me. We'll be here afterwards. And then, I'm sorry, Michael, I didn't leave you too much time here. My clock didn't work right. But this is Michael-Raposa from In Demand, everybody. Thanks for your time. Sorry about that.
Hello, my name is Michael-Raposa. I'm the VP of IT for In Demand Networks. In Demand Networks is the world leader of providing transactional video content. You probably heard of us if you have cable at home and you've ever ordered a movie on demand. That's us. We're owned by Comcast, Time Warner, and Cox, which together with just those owners are 30 million subscribers. I'm sorry, 40 million subscribers. And adding in our other affiliates like Cablevision, Rogers, Verizon, we basically cover over 90% of the cable TV universe. And we also have other pay-per-view programming like boxing, NHL, mixed martial arts, and Howard Stern. So the problem that we're dealing with, we have a 1.5 petabyte video archive. It's basically all of the movies that you can think of, the new classics like World War Z, the old classics from the 80s like Ice Pirates, and then ones that you've probably never heard of like Titanic 2, which you may have thought 5 miles down, being the Titanic, there'll never be a Titanic 2, but somehow they pulled it off. We deal constantly with physical tape storage, so, or at least we did. And all of the problems that revolve around physical tape storage. So lost tapes, tape corruption, we have to store tapes in multiple formats. There's a lot of physical storage with all of those tapes. So 1.5 petabytes is thousands and thousands of tapes, especially when you think about this as archive storage. So you want to store it multiple times in case there's any problems with one physical tape. It takes up a lot of space. We're based in Manhattan. Floor tile space is at a premium, and this actually adds a lot to our cost. And then I'm sure most of you are familiar with dealing with legacy tape formats like LTO and all of the different iterations that you need to go through as the technology changes and improves. We have a manual asset tracking system. So we have these thousands of tapes. On these tapes are movies like World War Z and Spider-Man, et cetera. It becomes very difficult to figure out what tape is storing what particular file. So for instance, is Spider-Man.mpeg stored on tape 123? Is that the HD version? Is it the SD version? Is it the MPEG-4 version? Is it the ProRes version? It's very difficult to determine just by looking at a name on a file name. And then finally, to do restores, we have a tape operator, a couple tape operators that run around, get requests from end users, then run to the tape library room, grab the tapes off the shelf, figure out what tapes they need to use, load them into the tape library, and then kick off all the restores. 2 days later, all of these restores are finally done, and the operations team can move on with the rest of the media workflow. And all of these things are expensive, right? We have to pay for the tape operator. We have to pay for the tape storage. I'm sure a lot of you in media entertainment know you're stuck on the tape drive and tape library windmill. So every 3 years, you have to upgrade your tape library array, or maybe 5 years, upgrade your tape library array. And it's basically a nuisance. It's a real problem that you have to deal with. And then these tape arrays, although you can buy some pretty big ones these days, they do have limited capacity. So whatever you buy on that particular day, you have to deal with for the next 3 to 5 years. Of course, there are upgrades available, but you don't have unlimited scale like you're going to have with something like AWS. So our solution is a mini DAM. We basically have created a digital asset management system, but a small one that sits in front of Glacier. So there's a web UI, very simple web UI, written in Python and Django that sits in front of Glacier and provides a simple digital asset management system. Glacier is the storage backend. It only cost us $50,000 to build. So a relatively cheap and quick application, and that's all in price. That includes the virtual machines, the EC2 instances, the development costs, the system architecture cost, all of that. Everything is hosted on Amazon, so we tried to leverage Amazon as much as possible. So RDS is where all the metadata is stored in a SQL database, MySQL database. We use the simple notification service to let us know when archives are available for download. We use the simple email service to email users when archives are available. And to date, we have over 300 terabytes in storage up at Glacier. And we're adding about 2 terabytes a day. By the end of the year, we'll have a direct connect to Amazon, and we're going to be increasing this number from 2 terabytes to 10 terabytes a day. So basically converting that entire video archive that we have on tape to Amazon. And here's a quick screenshot of the solution. So what you're looking at here is a user searching for Titanic 2, and they're searching through all of Glacier. And Glacier, by its very definition, is just a simple archive. Here, we're adding additional metadata and services on top of that. So you can see a user can search for, based on closed caption, DL as dual language, the bit rate, the duration of the movie, the aspect ratio, the video codec. And here you can download the different versions of Titanic 2. The last one on the list I happen to know is the HD version, encoded at 3.7 megabits per second. And they can drill in and see additional details. And here you're seeing the real link between the metadata portion and the Glacier archive. Up at the top is the Glacier archive ID, and now it's being linked to all of this metadata associated with the specific file. So again, we have basically a mini digital asset management system that was built extremely quickly and very easily. And you can scroll through each one of those different tabs for media info, video info, audio info, and get specific detail on that asset. And then, of course, you can click the download button and download the file. So some tips and tricks if you're looking to build a similar application. So first things first, you probably want a concurrent downloader. In all of the SDKs is a concurrent uploader. So you can upload to S3 and Glacier using multiple threads and high throughput, but there's really no concurrent downloader, which is odd because doing a backup, no one really cares about the time. Well, you care a little bit about the time that it takes, but when you need to do the restore is when someone wants the file instantaneously, and every second counts. So we at End Demand have written a concurrent downloader, added it into the Amazon SDK for Python, and it's a relatively simple thing to do. As you probably are aware, everything at Amazon is REST API and HTTP, HTTPS. A concurrent downloader is basically just using ranged gets to fire up multiple threads at the same time, and each thread is grabbing different ranges of the file concurrently. Then the file is being downloaded to the disk, all of those different bytes, and then combined together on disk. A reminder here that each archive that you store in Glacier has a 32 kilobyte overhead, and that is regardless of the size of the file. So if you happen to upload a file that's just 1 KB, don't forget you're actually going to be adding the 32 KB metadata on top of that. And that's metadata that Amazon adds to track the archive within Amazon Glacier. You are charged for this overhead. So if you have a lot of small files that you're uploading, for instance, for In Demand, we have SEC files, which are closed caption files. We don't just dump them into Glacier. We zip them up first, tar them up first, and then upload them. Download request timeouts. So if you recall back on that screenshot, you can search for a movie or an archive, hit the download button, and have it download. You wait the 3 to 5 hours for the file to get restored from Glacier and be available for download, and then you have 24 hours to download that file. If you don't download it in time, your timeout is basically expired, and you have to re-request the download. This problem occurs often when you have a user that's requesting multiple downloads at the same time. So if someone's asking for Saturday Night Live and they want seasons 1 through 6 all at once, that's a lot of downloads being kicked off. We can't download all of those files at the same time, so you have to put something in queue, queuing up those requests so that not all of the requests are made to Amazon Glacier at the same time and then hence lead to timeouts. This one I love. So Amazon Glacier is encrypted by default. You shouldn't have to add any encryption on, but adding additional encryption makes everyone happy. It makes the MPAA happy. They love encryption. And it makes management happy. They love encryption as well. One of the problems that I have dealing with Amazon and my own internal team is the fact that Amazon can be a bit of a black box, right? It's up in the cloud, it's somewhere in Reston, Virginia, or in the other zones, and it's not something that you can necessarily walk over and touch. So I like adding these additional features on top of things that Amazon already has because it makes people more comfortable with the solution. So my COO and CFO are much easier or are much more acceptable storing all of these very important assets up at Amazon if we're adding a layer of encryption on top of it. And I've run out of time. Just one more important point. Add checksums to the file. Calculate checksums before they go up to Amazon. This, again, deals with the black box problem. When you download a file, users will always end up complaining that there's something wrong with the file. You fire up your MD5 checksum, compare to the file what you uploaded to what you downloaded. If they're exactly the same, you know nothing happened up at Amazon. There was never any sort of issue. And again, overcome that black box. And then the last thing is just track who's requesting the downloads, because you do pay per download, and you can quickly, those fees can quickly start to add up. And again, we're out of time, so thank you. If you have any questions, feel free to ask.